Hello and welcome to the QA Therapy podcast. Are you looking to improve your overall testing and quality practices? My name is Sergio Freire and I'm Solution Architect and Testing Advocate at Xray.
And my name is Cristiano Cunha. I'm also a solution architect and test advocate, and will be your hosts and QA therapists throughout this series. As applications and services evolve into complex socio-technical systems, encompassing not just code but the environments they run in and the people who interact with them, diagnosing issues become increasingly challenging. While fast feedback loops, automation, and monitoring have been key tools, they are no longer enough to keep up with the complexity. Observability has emerged as a critical solution, providing the real time insights we need to truly understand what's happening in production and how it impacts both performance and users. In this episode, we explore how observability paired with exploratory testing help teams navigate this growing complexity. And to assist with us on this topic, we have a special guest with us, Charity Majors. But before welcoming her, let's just see what has brought you to listen to this podcast. So ask yourself, is your team blind to what's really happening in production? Or do you really solely rely on logs to understand your system behavior? Or even are you overwhelmed with production data and struggles to make sense of it?
These symptoms indicate that your systems lack proper observability or that your approach to it is ineffective, potentially causing more harm than good. When data is scattered across multiple unconnected sources, it becomes difficult or even impossible to make sense of it in a timely manner. This leads to guesswork instead of informed decision making, slowing down your ability to diagnose and fix issues. Let's dive deeper into diagnosing this problem and explore strategies for achieving that balance. Today, we are excited to welcome Charity Majors, a software engineer with a signature approach of being professionally care mad about computers. Charity is the CTO and co-founder of Honeycomb.io, where she advances observability for complex systems. Formerly a production engineering manager at Facebook, she also contributed to Parse and Second Life's infrastructure. Co-author of database reliability engineering, she's a passionate builder of systems, scaling solutions, and resilient engineering cultures. Welcome, Charity. Are you comfortable on our QA therapy couch?
I am. Thank you. Yes, it's nice and squishy. I appreciate the foam cushions.
Welcome, welcome.
Let's start our podcast. This word observability. Oh, it's so hard to
Many
say,
syllables.
to spell. What exactly does it mean? If you can give us an insight.
Yeah, when Christine and I started Honeycomb, which is coming up 8, almost 9 years. Oh my god. Uh, it wasn't really a word that was being used. Which is why we liked it, right? Because we were trying to do something that was very different. And for a few years, we staked out, we tried to define it as what ended up just being this laundry list of things like, well, it's high cardinality and high dimensionality and like wide events and everything. And then a couple of years into that, it started to catch on. And then like everybody was like, well, cool. So we do observability too. And then suddenly it becomes just this generic synonym for telemetry. These days, I like to say that observability is just a property of complex systems, just like reliability or performance, scalability. I don't want to jump too far ahead but I do feel like there's kind of a step function though between like technology that is very mature now, which is like 20, 30 years old, which is based on metrics, logs, and traces, and the sort of like emerging what we originally defined as observability, which now I guess I would call observability 2.0. And the difference between the two is that the 1.0 world is based on many pillars, so every request that enters your system, you capture it as metrics, as structured logs, as unstructured logs, as traces, as profiling, and a rum tool, and an APM tool, and analytics tools, and it's just like, and so you can see how it becomes very costly very quickly. And kind of the genesis of the 2.0 world is that you have a single source of truth. You've collected your telemetry in this very dense, wide way. You preserve the relationships between, the context, and therefore you can derive logs from it. You can derive metrics from it. You can visualize them over time as a trace. You can zoom in, you can zoom out, but because you've preserved so many webs of relationships between events, you only have to store it once, and you don't have to guess about how all of these data sets are connected.
Great definition, and you cover a lot of a lot of ground with
Yeah,
that
there's a
answer
lot
for
there.
sure.
Sorry.
Yeah, that's cool. On the other hand, we also going to talk a little bit about exploratory testing, and we want to a little bit explore the relationship between observability and exploratory testing. So, in your context, in your words, how do you see or what it is for you exploratory testing?
You know, an exploratory interface to your data has always been one of the real key principles of what observability means to us, because an artifact of the way things have always been was that you decided in advance which metrics you were going to collect, which dashboards you were going to populate, and increasingly, like, our systems are the complexity of our systems is increasing at a rate at which you increasingly just can't predict what's going to happen, what dashboards you're going to need, what metrics you're going to wish you had collected, and so having an interface that lets you slice and dice and interact with your data and zoom in and zoom out is, I think, becoming absolutely necessary for people who want to understand their systems. So I don't know if exploratory testing has like a formal definition in your world. Like, I don't come from the QA world. You called me a software engineer. I wouldn't actually call me a software engineer. I come from the ops world, and I feel like ops and QA are like cousins. We're like, neither of us is exactly software engineering. And I feel like historically QA has really focused in sort of pre-production stuff, and ops has really focused on post-production stuff. And I feel like kind of the beauty of what's happening now is that everything's shifting left, everything's shifting right. Production is like scooching back farther and farther in the development process, and the development process is scooching forward and forward into the production process. And so I feel like part of what exploratory testing means to me is that, kind of capturing what we said earlier about you can't predict what's going to happen. You can't predict what you're going to need to test either. And so capturing the data in a way that lets you explore it, that lets you like react to what's happening in real time and inspect it and sort of follow the trail of breadcrumbs wherever it leads, is, I think, a really key concept.
While you were talking, I was remember some projects that I tackled in the past, and I guess many teams come across with that approach. We start by implementing like logs in the system. At a given time, we start structure those logs, and then we start creating like events. Eventually, I remember creating like some scripts to do aggregated counts and store that on the database. Then someone asks, oh, but we need this and additional stuff. And then we have to implement something, another script to make that count. And I think there are still many teams like using still the approach of creating logs, or sometimes they create like predefined metrics and out to actually, for these people, what are they really missing? Because they are not really embedding the flexibility that you can have whenever you are adopting observability. Yeah, I think you tackle the like the zoom in, zoom out, the different, yeah, like the unknowns, right? Many times we don't know like the questions to ask, right?
Yeah,
And
absolutely.
from your perspective, observability is also like a tool for exploring like the unknowns in the product.
Yes. Yeah. In the early days, we used to talk about monitoring is for your known unknowns, and observability is for your unknown unknowns, right? It's all about equipping that future self, you at 2 a.m., weeks or months from now, or your coworker who's like, everything's screwed up. And, but also I feel like not just about the bugs and the outages and the downtime and the crashes. It's also just about understanding what you're unleashing into the world. Sometimes it's about understanding, what are people leaning into? What do they love? How are they using what you've built in unexpected ways? Like, if you are super locked into how you expected people to be using your system, you sometimes miss really exciting opportunities.
Good point. Very good point. Taking also a bit on that, and I'm already kind of diverting here, but um, thinking about also like the gaps, right? Charity. Many times we have like gaps in the product and when we are not aware of that. And sometimes observability can help us find if we have gaps in terms of
Absolutely.
features.
I need to take the cousins part because I really felt in the skin, not cousins, but testers as being the bridge between developers and operations, because testers was always keen into wanted to understand why that did not work in production and then bring back that message to developers. So I'm really aligned with what you said about cousins, and we are always talking about all of that. The other thing is that you guys were talking about logging and everything, but that really hit me when we started to have multi-region deployments, and it's not just fetching the logs of the application, is fetching and centralizing the logs and making sense of it to try to understand. So observability also exploded more on that sense of what you said, the one central place of truth. So it's really interesting, and that takes me to the next question. That is, when we talk about observability, when should teams start investing in observability? Do you think it's something that it's more of a when needed, even if because I was in teams that, well, we don't think about observability and performance and security from the start. We like focus on features and then let's see what happens next. But in your advice, what do you say to teams that want to invest in observability? Should they start early in the process before thinking about anything else? Is it something that can be built in? What's your take on that?
Just like there's no one right way to build an application, there's no one true way to do this. I do think that this is something, observability is one of those things that when you front load it, everything that comes after it becomes easier because you're no longer driving down the highway in the dark, you know? And I think that I think that engineers that learn to use the skill of observing their software in production, I think they start to feel like building without observability is building blindly, and they become aware of just how much friction there is and how much slower they go. I do think that there are some kinds of software where observability is less important. I think that we're seeing the explosion of like AI and a lot of generated code, and I think we're about to see the explosion of a lot of code that's basically disposable, where nobody ever really has to understand it or maintain it, where if it doesn't work, you just like throw it away and try again. But that is not most of the code that runs the world. The code that runs software that, like software that matters, software that's not toys, software that handles your banking and your deliveries and stuff. Uh, I think that the more you expect the code that you are writing to have a, a long life after you write it, the more costly it becomes to leave observability too late in the process. Because every time you have to iterate on it or fix it or make changes, the first thing you have to do is understand what's happening. And you want to do that the fast and easy and cheap way, based on instrumentation, not based on trying to read the code, add print statements, reconstruct what the what the hell is going on. Like you're making it easier for your future self if you get good at observability and then you front load it, because everything that you want to do afterwards just becomes that much easier. It's also kind of a translation language between teams or between engineers. If you're working on an endpoint or something and you're the only one working on it, and when you're done, then it's not that hard to keep it all in here. But if that code is getting passed around across time, across teams, if other teams are needing to interact with it, if other people who are not maybe on your team then like I think you're really doing everyone a disservice if you don't front load the observability.
You mentioned, let's say, or we mentioned at the given point, like the complex applications topic. Do you think that this is only like a thing that is essential for complex applications, and how can we really define what complex applications mean currently?
Oh, that's such a great question. And I'm sure there's some very mathy answer to that out there. But like, I'm a music major dropout. I come from operations. I have a much more impressionistic sense of complexity. And I think that things that make systems complex are age, rate of change, and the number of jobs that they're trying to do. Now one thing that I think really kind of like, if there was one thing that I think sort of like pushed us over the, like when Christine and I started Honeycomb, we really thought this was going to be a niche problem that only very large multi-tenant platforms were going to have. And over the course of the first few years, we started to realize, oh no, this is becoming an everyone problem. And that really coincided with the rise of microservices, blowing up your monolith, distributing it across. Now suddenly you're not just calling another function. You can't attach a tracer or a debugger to this anymore. Now you're hopping the network all over the place, right? And so it pushed a lot of the operational complexity into the realm of software engineering. And that I think was a big tipping point for a lot of folks.
And I want to take a little bit what you say at the beginning between the differences in observability 1.0 and 2.0. And I'm curious to hear if you think that it's a natural evolution, like teams and applications can starting observability 1.0 with those three pillars and then evolve into 2.0, or can they just straight go to 2.0 and go for it?
They can, but they shouldn't, because actually 2.0 is so much easier, simpler, cheaper, more intuitive. The way people are doing things now is the hard way. It is so hard to try and educate all your engineers about when to use a metric, when to use a log, what type of metric to use, whether you want a gauge or a counter or how high a cardinality the data underneath it is going to be, what that's going to do to your cost profile. What if you're duplicating data across this team and that team, or this tool and that tool? And what about, it's really hard. I know entire like world-class observability engineering teams that spend an outright majority of their time just trying to govern the sort of trade-offs between cost and cardinality, enough cardinality to understand your systems, not so much that it sends you bankrupt, right? And like that's all they do. That's almost all that they do. And it's so costly, it's so expensive, and you kind of have to learn the language of operations too. You can't just be a software engineer dealing with the language of functions and variables and API endpoints, which, there's so much friction involved. The only reason like people don't see all the labor and the work and the difficulties because we've been doing it for 30 years. But if you put a 2.0 tool in front of a new grad software engineer or a 1.0 suite of tools in front of like they can pick up the 2.0 tooling just like that in comparison. It's intuitive. You don't have to worry about cardinality. Stuff everything that you want in there, right? Because it's about how wide the events are. You send fewer events, but they're wider. Anything you think might be useful to future you stuff it in there. And you only have to capture it once, right? And then you can automatically trace it or draw it. It's so much simpler. The cost thing in the post-zero interest rate phenomenon era is really driving a lot of companies to make the move, because yes, 2.0 is easier, faster, cheaper, blah, 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 but it's also change, right? And change is always hard. But so many folks are just experiencing a cost explosion from every request that enters their system. They have to capture it in 7 or 10 different tools, and nothing connects those tools except the poor engineer who's sitting in the middle going, well, that shape looks like that shape. They're probably the same thing. Nobody can tell, right? There's no connector tissue, but they're probably the same thing. And like, well, here's something in my logs, but I want the trace. I'm going to copy paste the ID from this tool to that tool and hope it didn't get sampled out. It's so lossy. And this is, I think, one of the interesting things about the socio-technical things about 1.0 to 2.0 is that 1.0 is really about how you operate your code. And 2.0 is really about how you develop your code. You're talking about the feedback loops, right? Good observability 2.0 is what underpins those feedback loops so that you can make them tight and small and fast and not lossy, right? So you can get this rhythm of writing code, instrumenting it as you go, looking at it in production minutes later and going, is it doing what I expect it to do? Does anything else look weird? Right? And like keeping that interval tight is like the closest thing we have to a Rosetta Stone when it comes to enabling us to move really fast with a lot of confidence in software.
Whenever I talk about building an observable system from the ground, what kind of investments in terms of toolings, in terms of process, should teams make in order for that to happen?
Well, I mean, it's hard to generalize between like, I was just talking to the ING Bank with 17,000 engineers, right? And like a startup that's just starting up. Um, but like, so it depends on where you're starting from, and it depends on what you've got and everything. But I think at minimum, you need a place to put your data. You need a philosophy for what kind of data to capture, when and why. And I think if I was starting off these days, I would really encourage people to pick a 2.0 system. And I've ranted a lot about dashboards in the past. I want to be clear. Static dashboards are not a debugging tool. Dynamic dashboards you can interact with are a debugging tool. I'm not saying all dashboards are bad, but I'm just saying that like the static dashboards have this tendency to proliferate. Now you've got 10,000 dashboards. Which one do you want? Being able to interact with your data, I think, is really important for like keeping in sync the sort of like theory of mind that you have about your software and making sure that it's up to date and accurate.
And we're talking about observability and the advantages of it, but what are the risks of not having observability or having poor or inadequate observability? I think we touched it a little bit, but just to
Yeah,
sum it up.
yeah. It's like throwing sand in the gears. Everything slows down because everything has to be done manually by like trying to read your code or trying to like interact with production systems, which means you got to get a deploy out. Every time you want to understand something, you have to try and deploy more instrumentation, right? Or it means like that you don't find bugs. It means that your customers are reporting bugs to you because you can't find them before they do, right? It means that your everything slows down when it comes to writing and shipping software, because anytime you need to make a change to any existing code, uh, it should be pretty easy, right? You should be able to get in, understand the code, see how it's working. But like, I think of observability sometimes as your production documentation is the only accurate-ish documentation you can trust, because it's reporting back to you what it's seeing in production right now. It's not what somebody who wrote it 2 years ago thinks should be happening. It's what is happening, right? And if you don't have observability, you don't have that ability to like interrogate your systems and find out what actually is happening. And that's actually a very scary place to be.
Another thing that made me thought a long time ago is about, well, we can think about observability as a way to support, let's say, the development team, but I also was thinking about using observability as a property, as a tooling in a certain way to support different sets of teams within a bigger team. I mean, like supporting the support team, supporting the dev team, supporting the testing team, supporting the sales team. Uh, in my experience, I've been like seeing all these internal teams working using different tools, and they have like support cases, but they don't know exactly what is happening in production. Then they have the dev team, and the dev team
Yeah.
has their own tools. The
Yes.
sales team talks about features, that tries to sell the feature, but they don't understand exactly if what are like the features that interest most. Can observability tools also be used to bridge the gaps of these different worlds within the
I
organizations?
have said so many times that I think that the edges of tools are what create silos. When you've got every team having its own source of truth, then when you need to solve a problem together, you often spend more time and energy arguing about the nature of reality than trying to solve the problem that you're trying to solve together, because everybody's got their own perspective, right? And I think that that is one of the big risks of having everybody decide, up front, here's how we're going to capture our data, and you're going to capture your data. I think that like, something I often think about, these engineering adjacent teams, right? Where they aren't writing code every day, but they are interacting with the same data. And it's an enormous tax on the engineering teams if engineers have to translate their data for other teams, right? Or serve that data to them. Something we saw at Slack, like when we started working with them years ago, the support team didn't have any independent ability to like verify if if someone writes a support, says they have a problem, support team couldn't verify that. And being able to offer up the same data to like slice and dice and introspect and like made it so that they could verify whether something was real or not before they handed it off to engineers. And I think that like having fewer sources of truth, um, and aligning around them is one of the great unifying things that you can do for a company.
The other thing I think about, and most of the companies and teams are afraid of, is testing in production. And when we talk about observability, if we are able to understand what is happening in real life, in real time, to your production environment, in my mind, it should help testing in production. Of course, if you have the conditions to do so and everything. Do you think observability really help into converting teams into testing in production? Because there's a fear there in my
Easy.
previous experience that, yeah, bless you.
Yes. No, you're absolutely right. Usually I often wear a shirt that says test and prod or live a lie. And so like often people ask,
That's
they'll
a
be
good
like,
one.
testing in production makes my manager really, really scared. So like how can I get them comfortable with it? And the first thing I say is, well, don't use those words. Talk about validating in reality or something like that. Because it sounds scary, right? But it's not. Everyone tests in production. If you say you don't, you're lying to yourself. And if you're lying to yourself about whether or not you're doing it, this just means you're not going to invest in the tools to do it well. So you're always going to be flying by the seat of your pants, just like doing the best you can with what you got, which is not great, right? There are lots of tried and true, time tested ways to test your code in production, whether that's like using feature flags to separate deploys from releases, have special test class of users in production where you can attach special payloads to them and trace them all the way through or something. You can fork traffic and take a copy of it offline so you can do whatever the hell you want with it. There's all kinds of really great things that you can do, but if you don't have an observable system, you can't do any of them. A lot of people talk about security risks. It is such a security risk to not have good observability tooling, because then somebody's going to have to SSH in, right? Or do something terrible to find. You can't not understand your systems at the end of the day, right? And so if they don't have the tools to do this well and safely and securely, they're going to do it badly, right? There's no way around it. And I really feel like the industry has come such a long way in the last few years when it comes to just like understanding this as a principle and investing. The other thing about this is that engineering cycles are the scarcest resource in every one of our universes, right? We all are bounded by the same pool of engineers. We draw from that pool of engineering resources when we build features, when we fix bugs, when we invest in tooling, right? And for a long, long time, I feel like in the industry, there was such a fear of production that we took too many of those engineering cycles and tried to pay down, tried to make everything perfect before it entered production. And so we were starving ourselves of resources to invest in production because we were sending so many of them to pre-production hardening. And the fact is that like you reach diminishing returns so fast. And most companies have nowhere near started reaching diminishing returns when it comes to investing in their production systems.
Before asking one tough question, I was also remembering like another thing that I usually see in some tools more related with monitoring. Actually, some of these tools, they also have like synthetic monitoring. This is something that we can complement these different approaches to have better insights, right? They are not really exclusive, right? Sometimes people think that, okay, we have just logs, or we have just monitoring, or you just have like alarms, but like the different approaches, they can complement one another, right?
Yeah, 100%.
So my tough question, Charity, is what are like your top favorite tools for observability? And you cannot say one with H in the ending with .io. You can mention it. That's all fine,
Yeah.
all fine.
The first thing I'll mention is something I already mentioned, which is feature flags. They are an indispensable tool for modern systems. I mean, just for separating releases from deploys alone, and not everyone knows what I mean by that, so I'll explain it really quickly. We know that the best thing you can do for stable, reliable systems is to move fast, is to be constantly shipping small changes, right? And yet other parts of the company have very different needs, right? Marketing and product need to have release days where we release big new features and unlock new functionality, right? So these are like opposing needs. And we can have both things with feature flags. We can be constantly shipping small changes for engineering's perspective, and we can have these big bang releases, like we're turning it on at 10 a.m. on Wednesday, and everyone will see it from, and which is great because we can make sure that code is working before 10 a.m. We can also do things like have, preview users where a slice of people get to try it out, right? Or internal users get to try it out. Just getting this very fine-grained control over what's going on in production is really important, I think, to sort of smoothing out some of these bumps. Oh gosh, what would another
Observability and any tool that you remember that comes to your mind. Honeycomb.
I'm going to say something. I'm going to say ClickHouse. I think that there are a lot of folks out there who are kind of looking at what we're talking about with Observability 2.0 and going, okay, how do I build my own, or what's an open source analog, or, and I think that until this year, we haven't really had great answers for them. And like some people would be like, well, maybe you don't want the competition. No, we want the competition because I'm so confident that this is a better world to be in, that like I want all of us to be competing on this Observability 2.0 landscape because it's better for developers and it's better for users, right? And I think that you've seen this rise in the past couple of years of like ClickHouse and DuckDB and like these columnar databases. And I think that like over the next year or so, you're going to see more and more sort of like composable, like elk analogs, right? Where you had Elastic and Logstash and Kibana, and you could hack together your own, and there would be hosted versions. I think we're starting to see these sort of things emerge. And so I'll say that I think that like the reason columnar databases are so critical to Observability 2.0 tooling is that they're what power the ability to slice and dice, to not have to pick indexes in advance, or not have to pick and choose what is going to be fast and what's going to be slow, but to just be able to slice and, because a columnar database is basically every single, instead of rows, you have columns, right? Every dimension is already an index. And so you can break down and group by and explore and zoom in and zoom out. You can't do this without columnar databases. Now, the exploratory testing part,
great advice. I love
is still trying to get there. Is the exploratory interface, the visualization layer. Grafana is not really built around these principles, and so it's a little manual. My feelers are out. I gotta imagine some things are going to emerge because there's so much exciting stuff going on in this space. But like, the exploratory interface isn't quite there yet, but I have confidence it is coming.
I have one last question, that is, if our listeners want to learn more about observability, do you have any resource that you want to share, any site or
honestly,
something
the
that you
Honeycomb
can
blog
go and learn more about it?
The Honeycomb blog is, I think, the single best place you can go to find, and it's not just stuff about Honeycomb. We talk about tracing and instrumentation and migrations and rolling your own, and we do case studies. We're really trying to bring the whole industry forward. So honeycomb.io/blog. There's also my blog at charity.wtf. And there's this one thing that Jeremy Morrill wrote, which I'll send you guys the URL if you can put it in the show notes. It is so good. He wrote A Practitioner's Guide to Wide Events. It is the single, he out honeycomb, right? It's vendor neutral, and he talked about how to instrument your code for modern purposes using wide events, traceable events, metrics, etc. It has code examples, it has snippets, it has heat maps, it has hand-drawn diagrams, it has attributes. It is so
all the
good.
Stuff.
Everyone should bookmark this and like refer to this every time you have any kind of instrumentation challenges, because you asked earlier in the episode if there's a way to get from 1.0 to 2.0, and there is. Actually, I just wrote a white paper about this last week. The bridge from 1.0 to 2.0 is logs. It's not metrics. Like right now, I think most tools in the space are built on top of metrics, and so like 80% of what we do is metrics, like 20% is logs. Those ratios need to invert. Logs have the capacity to preserve relationships between metrics. A metric is just a number. There's no relation. It stores no relational data whatsoever. And so you have to store it again and again and again and again and again and again and again. Logs preserve those relationships. And so if people want to take away one thing, it's like Stop investing in your metric solutions. Start investing in your logs. I wrote a whole white paper about like the steps you can take and everything. And this thing that Jeremy Morrill wrote, again, A Practitioner's Guide to Wide Events by Jeremy Morrill, 2 R's, 2 L's. It's so good. It's so good.
Thank you, Charity. I remember reading like a white paper also on your website, I think from 3 years ago on observability. It was really good and really clear, explaining the concepts, at least to me.
Thank you.
Once again, you're welcome. Once again, thank you for being here with us, Charity. It was really a pleasure, and finally having this opportunity to meet, even if it's remotely, and discussing these topics that resonate so much with also with testing and making better software. Thank you.
Thanks for having me. This was really fun.
Yeah, I hope that you liked it too, but it was really fun for me. So thank
It's
you for being
great.
here.